Yo, you want a life with fast cars and big toys? Well, it starts right here. It starts right now. So there's three things you gotta know. 1. What the parts do. 2. What the parts are. And 3. How to fix it when it broke. So follow the 3 tracks and get cracking. Once upon a time in the 60s, some mechanics and engineers got together to build a dragon. Mechanics are those people with the passion and ability to create, fix, and get it right. They had this crazy idea of building the ultimate hydroplane. These engineers and mechanics designed a perfectly balanced 7,000-pound hydroplane with a 3,000 horsepower Rolls-Royce Merlin fighter plane engine that could skim across the water at 180 miles per hour.
And Miss Bardall throwing that rooster tail, leveled off, a boat that is turning in the best time in winning both heats. He averaged 109 miles an hour in the second 15 miles, about 104 miles an hour in the first 15 miles. And look at that boat rock, a little shaky over there. And Ron sort of backs off, takes it easy. The rooster tail turns. Boy, what a maneuver he made here in the last lap when he got past US 1 on the inside.
The team turned mechanical sciences into a legendary art form that delivered championships from 1962 to 1965. Great mechanics fix things better than before. To get it right is more than just a saying, it is a way of life. Years later, they found the old boat and convinced its owner to sell it back to them for only $1. Within that, the mechanic Dixon Smith's quest to get it right once again begins. Through experience they gained years ago, the team navigates through mechanical layers of physical sciences, fixing to improve the flawless performance, keeping its original dream intact. Mechanics have a sense of responsibility in owning how well something performs and lasts. They know the risks and are deeply aware of the faith drivers have in their work. Great mechanics and engineers leave a piece of themselves in everything they work on. There is an awesome feeling in seeing something done just right. There is a sense that they can bring things to life, make the world run, and in this case even roar. When all is said and done, the ultimate test is, will it turn on? Will it fly? Roll? Everything you know and do comes down to one moment. You hit the switch. So what is the life of a mechanic? From minivans to attack helicopters and Miss Bartle, it is the privilege to be part of the dreamers who engineer and build and race the world.
Welcome to 4 strokes. Why 4 strokes? Basically, we have to take in a controlled explosion and deal with the pressures and forces to make a crankshaft spin, or a drive shaft spin. First, we have to get fuel and gas mixture into the engine. Second, we have to compress it till it's ready to explode it. Third, we have to transfer the power of that explosion onto the crankshaft that's spinning. And we have to get rid of the exhaust and ready ourselves for our first take. So let's go in depth of each of the 4 strokes and how they work. The first of the 4 strokes is the intake. Here we take gas and air mixture. The piston moves down, so the first stroke is a downstroke. The valve opens up on the intake. The piston drops, making a vacuum. The vacuum sucks the glass in, and the mixture is in the cylinder. And here the crankshaft spins and is ready for the next stroke. Now we're ready for our second stroke. Once the gas is in, the piston rides up. There's less space. It compresses the air to the point of explosion. When it gets top dead center, all the way to the top, the spark explodes, ready to rotate and to spin for the downstroke. Our third stroke is the power stroke. Once we have an explosion, the gas expands, rams the piston down, and the piston turns the crankshaft. Our fourth and last stroke is the exhaust stroke. Our gases are burnt, the exhaust valve opens up, piston moves up, exhaust rushes out, and we are ready for the first stroke to take place. That ends the process of the 4 strokes. We cannot stress how important exact engineering is in dealing with engines. This is the fatal crash of Scott Kalita. This funny car at 300 miles an hour exploded, burned up, and then hit a wall at the end of the track. Timing is essential. Understanding pressure and the forces that at bay are all essential things. When we look at an engine or take it apart, it must be precisely put back together. This is true for race cars, boats, planes, and even for the standard car. Caution and exact science and no horsing around are the things of the day. This review slide is here to help you with your quiz that comes after it. There are 2 slides. This first one is to help you with the strokes. First of all, take a look at the name of each stroke. See if you can describe what the stroke does and what the parts are. Then click on the bar and see what the answer is. Well, just about all of us know some of the parts of the engine. So go down the list on the right, take your cursor, point on the engine of the moving parts, see which ones that you can name, where they are, and then you will see the names pop up over to the left. Good luck, and then we'll move on with naming the parts of the engine and what they do in relationship to the 4 strokes. It is important to understand the parts and how they work in relationship to one another. On the intake stroke, first it starts with a carburetor mixing gas and air together. It goes through an intake, then a cam, rotating cam, pushes down on the intake valve, compresses the spring, and opens up that valve so the gas can get in. The piston rings create a suction around the piston as they pull down. The piston rod is connected to the crankshaft, which spins around, pulling the piston down, and then the crankshaft does the work. This is the essence of how we take gas and we bring it into the engine. Now you're going to see how timing works. In the compression stroke, the cams spin around and release the valve strings so they tighten up the valves. The crankshaft is spinning and it pushes the piston rod up. The rings create pressure as the piston drives up the cylinder, and when it gets all the way to the top, the spark plug ignites it. Once that explosion takes place, the cams stay shut, the valve springs hold them shut, and the intake and exhaust valves are tightly sealed, containing all the pressure of the explosion. The piston is driven down by the pressure that the piston rings hold. The piston rod holding the camshaft spins it, and this is the power stroke. Once the gas has been spent and the piston is pushed down, spinning the crankshaft, the cam will open up the exhaust valve. The crankshaft, still spinning, will push the rod up, the piston will go up, piston rings create pressure, and push the exhaust outside the exhaust manifold. This completes the fourth and final cycle of the four-stroke engine. Of course, timing, movement of valves, crankshaft, pistons, everything must be perfect. Okay, hotshot, we know you got all of this, so let's see you match up all the parts with the boxes and see how you do. Welcome to the troubleshooting section of our course. You can't see all the parts that are moving inside the engine, but there is a great diagnostic tool, and that is the spark plug. Spark plug allows you to take a look at it, listen to the symptoms that the customer or your family might have with the issues on the car, take a look at and propose some of the causes, and then come up with a remedy of it. We'll do this through a series of spark plugs. Let's start with a normal plug. This is a normal plug, normal car, good maintenance. As you can see, it's just the wear is clean, it is white, and you may see this only because they're losing a little bit of horsepower or it's just regular maintenance. But this is basically how a plug should work or look. The cause of this kind of plug is pretty simple, just regular maintenance in a healthy car. Now, just because one plug looks great like this doesn't mean the rest of the cylinders will have the same thing, because wear on different cylinders can happen at different times and for different reasons. So you still must pull all of the plugs to change anyway and lay them down on the table for the customer to see that all is either healthy or there's an issue. In this case, the remedy is simple, just a simple routine maintenance job, changing oil, checking over the rest of the parts of the car, and you're good to go. Now, the customer may come in and complain that they're seeing gray smoke or white smoke coming out of their exhaust or even some misfiring. This is not good, and this is what that plug is most likely to look like. Now, the cause of this can be a bunch of pricey things. The rings could be worn, piston can be worn, leaky valve stems, oil filter slump, a whole series of different things that will require taking the engine apart to look at. Again, all the other plugs may look fine, but maybe one plug looks this way, or two plugs this way. If only one plug this way, then its chances are it's something like rings. If all of them, then it's a more global situation. Now, looking at this kind of plug doesn't give you a total remedy. There's many other factors that go into why your engine may be leaking oil. But at least it warns you and tells you the problem, and to discuss with your customer on what the options are. Here a customer may come in with classic pinging, or it just doesn't have enough power, or maybe the engine diesels when you turn the engine off. Very embarrassing thing. Again, it doesn't give you a total conclusion, but it gives you an idea of where to look. This is the type of plug you may see. Unlike the oil spark plug, this isn't the end of the world. The cause may be things that are actually easy to fix. A lean mixture, taking a look at the timing, maybe the spark plug that were in there that were too hot, or even changing gas. But there are some simple solutions to this one. So our remedies for an overheated spark plug may be fairly simple. Take a look at jets, your float levels, ignition timing, or maybe even that's just the wrong spark plug that was put in. Put one in with the right heat range. Now, some symptoms are pretty dramatic. Misfiring, loss of power, car being hard to start, and worse yet, noise in the engine. If you're holding this spark plug in your hand, you have a truly ugly situation. In order for a plug to look like this, something must strike it, which means there must be something inside the engine, maybe a valve's broken, or some other object. But there's no other way. You must have to do something dramatic to take a look at what the problem is and fix it. If something is banging around the inside of that cylinder, simply replacing the spark plug is not going to do. You must prepare the customer for the worst. Maybe the engine needs to be replaced. It is not often for a customer to take too long between tune-ups, particularly on old cars. They can just get hard starting, fuel economy goes down, and you just have to come in and do it. This is most typically when you'll see a worn plug. Now, worn-out plugs could look like this, but they could also be a little bit more black and charred. But either way, you can see the tips are basically worn out over time. Carbon, lead, additives, salts, all these things just dissolve the plug. And a simple replacement of the plug is all you need to do. Now, I know it says here just to replace the plug, but the heat range is the key thing. Oftentimes, people are speedy when they buy plugs in stores, and they don't really check if it's the right heat range, a hot or a cold plug. So this is a good time to check and make sure you're putting the right plug in. The lazy thing is to do is just take a look at the number, replace it with the same plug. Don't do that. Look at the chart, make sure the right plug with the right heat is going to be put back into the car. In this next review slide, think of yourself in the garage. Customer comes up to you with these complaints. Think of the type of plug you'll probably see, what the causes are, and what the remedies are. Then click on the bar, look at the pull down, and see how accurate you are. Okay, so now is your time to prove what you know. Simply take the picture of the spark plug and drag it on top of the description.
When you are an engineer or a mechanic, every part has a story to tell. You understand the violent forces of controlled explosions. Internal combustion engines leave their telltale marks on every part. The mechanic must be both detective and doctor. When a mechanic picks up a part, they look at how it is worn. This one is in great condition. It's well oiled, no signs of burns or nicks. Even the piston pin is tight and rotates smoothly. This is from an either newer engine or a well-maintained engine. In contrast to the new piston, the connecting rod here is one that's well worn. The top is covered with carbon burns. Was spark plug the wrong temperature? Is the oil ring on the pistons leaky? Is this an ignition problem? All detective things the mechanic must figure out. Mechanics are physical law detectives. Each piston cylinder tells us its own story, while at the same time, the whole story of how the engine is burning gas is also quite evident. We can see how one cylinder has more carbon buildup and the others are fine. Each anomaly evokes more questions as to what is taking place. Over time, you will develop a keen sense of touch and sound for mechanical parts. This comes with experience. Unlike working in factory parts, it can be frozen, old threads can be dirty, and everything must be cleaned before going back together. Touch and pressure can only be mastered over time. At what point will a bolt snap, break, or a belt wear out? This is the mechanic's educated guess. Engineers and mechanics are a breed that is constantly searching, understand, fix, improve their world. It is a life that provides gratification from the concrete improvements they brought to the world while supporting their children.
Oh, hey, you're still here. I've been thinking about that question you asked. What about trust? Someone trusts that when they fly a plane that they'll make it home to their kids. On a snowy day when they hit the brakes at an intersection that they're not going to pass through and get hit. Trust when they turn an engine on it will work. that the bridge will stand up, caring that you do the best job, that you leave your mark on everything you do. I guess that's the type of person an engineer is, or a mechanic, at least a good one. So, if I had to sum it up in one word, trust would be pretty good. And remember to put your tools away.